Geometry, kind of, I guess I would call it SMART Goal 1 review. One of the first questions you get asked here, it talks about the measure of an angle and its supplement. And it wants to know what is the measure of each. So I'm going to change it up a little bit just so that I'm not giving you the answer to the question. But it says the measure of an angle and its supplement. So the measure of an angle is, let's say it's 4 times its supplement. What do we know about supplementary angles? They add up to 180. So, all right, so I know I have something plus something else, and I know it equals 180, right? All right, let me pause here for a second while I recalibrate my smart board because it's all over the place. All right, so when we're looking at this question, we should at least be able to start with something plus something equals 180, right? So it tells me, and if I'm trying not to give you the question that's asked, I've got an angle and it's 2 times its supplement, or 3 times its supplement. Let's say 4 times its supplement for this matter, okay? 4 times its supplement. So that means that an angle is 4 times another angle, right? But they add up to 180. It would be, let's look at it like this. Let's say that this angle is x, right? And I'm telling you that an angle is 4 times this. So what is the first angle? No. Which would be 4x, right? So this angle is 4 times that angle, right? Oh, okay, all right. Now, what can I do with those 2 things? Combine them and get 5x. So 5x equals 180. Divide by 5. Okay. Is it 36? All right, so the question that gets asked is, what is each angle? Well, this angle right here is 36 degrees, right? All right, so how do I find out what this one is? Plug it in. What's 4 times 6? So 144 degrees and 36 degrees. All right, that's how we do that question. So if they said an angle is 2 times its supplement, this would be 2x, this would be x, right? I get 3x, right, equals 180 divided by 3, right? That's going to give me 1, and then I'm going to plug it back in to get the other. Does that make sense? You can't look at the notes, but if I tell you, hey, we're going to do SMART goal number 1, right, you should be reviewing. Okay, does that help? All right, let's take a look at another question. All right, this one I think you guys did fairly well on. I don't know, I mean, this one is talking about reflection across an axis, okay? And you get something, it's going to look a little bit like this, right? And I think it probably says reflect this across the x-axis, right? Now, I'm just going to tell you the easiest thing to do rather than trying to physically do this is to find a rule. Okay, so if I find a rule, then all I really need are these coordinates. So let's say, this coordinate here is -2, 10, right? Let's say this is 4, 10. Let's say this down here is 4, 5. Does that work? All right. If I want to reflect something across the x-axis, okay, meaning I'm going to bring, this is going to come down here, this is going to come down here, this is going to come down here, I'll end up with something that looks, pretty much like that. Okay, it's reflected. Does that make sense? But if I know the rule for reflecting across something across the x-axis, I don't have to count and move and do all this kind of different stuff. Okay? Okay, go ahead.
Your x stay the same, but your y turns into a negative.
Your y becomes the opposite. Right. So x stays the same, and then y becomes the opposite sign. If I'm coming from the positive side of the x-axis and I'm going down to the negative side of the x-axis, right, the x values don't move, right? I didn't move left or right at all. All I did was flip everything down the same distance across the x-axis as it was. So I already know, I don't even have to think about it. I know that I'm going to get -2, -10. I'm going to get 4, -10. And I'm going to get 4, -5. I don't even have to draw the picture because I believe in this question, all they're asking for are the coordinates of the vertices. Okay? Does that make sense? All right, so if I'm reflecting across the x-axis from the positive side down, and really the same thing is true going the other way. I'm just all this minus sign here means is change the sign. So it could be going from negative to positive. So if I was going from 4, -5 across the x-axis, I would get 4, 5 because 5 is the opposite of -5. Okay, so this is a rule for the x-axis, right? For reflection across the x-axis. Okay, is this rule right here. Now, just so that you're aware, we also have a rule for flipping something across the y-axis, which is xy to the -xy. In that case, the y doesn't change, but the x changes signs. Okay? Right. If I was going to reflect across the x-axis and then across the y-axis, yes, I would flip both signs.
But wouldn't your numbers be different then?
No, not if you're reflecting and then reflecting again.
Like if you say it's right here, if you reflect it over here.
I mean, we're going to get into transformations in third quarter, and so all of this will end up hitting on this again then. So I can go into the finer details of what you're asking then. Okay, but for now, I just want you to understand what this question is getting to. Does this make sense? Okay. All right, let's take a look at another. This one is rotational symmetry. Okay, you're given a question, what looks like a flower, right? Okay, so you got something like this, and then, okay, and it says, you know, what is the rotational symmetry of this where it's going to map back onto itself, right? Is that fairly familiar? Okay, it's going to look a little bit different than this, but essentially, I'm going to kind of narrow this down, is that I want the blue to map back onto the blue, right? And so that's going to happen once, twice, 3 times, and it's going to come back around 4 times, right? So the rotational symmetry here is every 90 degrees, okay, because that's 360 divided by 4. So it maps back onto itself 4 times. It does that every 90 degrees. So, like, let's say we had something like this. What is the rotational symmetry of that? 180 degrees. Okay. What is the rotational symmetry of this? No. Look, here, and he found 180 degrees by taking 360 and doing what with it? If you did, it's 120 degrees. Now, does that change at all if I do this? It does? No? No. No, no, no. Because I still want red to map onto red. I don't want red to map onto blue. That's not the same thing. That doesn't map. It stays the same. So just because there's more petals, if those petals are different onto a purple petal. You follow me? I need the same color to map onto itself. So in this case, it's 120 degrees. You follow me? All right, so that's rotational symmetry. Okay, take a look at another. Then we have combinations of transformations. Okay, this one, it'll be a little bit easier as we look into some other stuff, but I think most of you kind of did all right on that one. All right, let's talk about this for a second, where we have something, let's put it here, I guess, and we want to reflect across a line that is not an axis. So let's say y equals, give me a number, give me a fairly small number. It could be positive or negative. 2. Let's say like -3. -3. Okay. So we'll go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3. Well, call that 1, 4. All right. So the first thing I want to do with this is I want to identify the line that I'm trying to reflect across. Okay. If I'm reflecting across the line y equals -3, we'll say that this line kind of comes across here, goes up to there. This is what I get whenever I try to hand draw a coordinate plane and put something on it. But this is the line I want to reflect across. Okay? So what I'm looking at then is I need to go the same distance. So this point comes to here. This point comes to here. Okay, so if I label this A, B, C, D, this is what we call C prime and D prime. Okay, now if this goes, what, 1, 2, 3, then my next points are going to go down 3 from there. So 1, 2, 3. Okay, so I wind up here and here with A prime and B prime. Okay, so then I'm looking at these coordinates as they're listed. Does that make? There's not a formula for this because there's really an infinite number of different types of lines that we could reflect across. Now, there are some other lines that have rules. Like if I was going to reflect across the line y equals x, there's a rule for that. Okay, but not for this because, I mean, y equals -3 is not going to get its own rule. You follow me? All right, so then I would need the coordinates here, but that's really just a matter of counting x's and y's, right? Counting to the left, counting up or down, that type of thing. So do we understand what we're looking at here? A little bit? Yes? No? Okay. Let's see, I think that's it really for question number, or for SMART Goal 1. Hopefully we understand that a little bit better.